Imagine you could take an ordinary piece of wood and turn it into something extraordinary, something almost as hard as steel. Well, that's exactly what scientists at the University of Toronto have done. They took a close look at a special material called biochar. Now, what is biochar? It's basically wood that has been cooked in a very special way. You heat it up in a place with no oxygen, a process called pyrolysis. Think of it like baking a cake in an oven that's been sealed shut, so no air can get in. The wood doesn't burn into ash. Instead, it transforms into a black, carbon-rich substance that looks a lot like charcoal. This isn't your average barbecue charcoal, though. This stuff is different. The scientists discovered that when they made biochar from certain types of dense wood, like African ironwood, it became incredibly hard. How hard? They found it could be as tough as mild steel. But here's the really cool part. It's only that strong in one direction. It's like a superhero who is super strong when pushing forward, but not as strong when pushing from the side. This one-way strength is a property we call anisotropy, and it's all thanks to the wood's original natural structure that gets locked into place. So, how did they figure this out? The research team, led by Professor Charles Gia, didn't just test one kind of wood. They experimented with 7 different types, including pine, maple, and even bamboo. They cooked these woods at very high temperatures, ranging from 600 to 1000 degrees Celsius. By doing this, they learned that the type of wood you start with and the temperature you cook it at are super important. It's like following a recipe. Different ingredients and different temperatures give you a different kind of cake, and in this case, a different kind of super strong biochar. This discovery, published just last month in October 2025, changes everything we thought we knew about biochar. For a long time, people have known that biochar is great for gardens. You can mix it into the soil to help plants grow better and to store carbon, which is good for our planet. But nobody really thought of it as a material you could build things with. Now, we know it can be more than just a soil helper. It has the potential to be a strong, lightweight, and green building block for a whole new generation of amazing inventions. Consider this. Why is this biochar so strong in one direction but not the other? The answer isn't in the black carbon itself, but in the amazing structure it inherits from the tree it came from. If you were to look at a piece of wood under a microscope, you would see that it's not a solid block. It's made of tiny, long tubes or channels, all lined up together. These tubes are like a bundle of drinking straws. Their job in the living tree is to carry water and nutrients from the roots all the way up to the leaves. This structure is what gives a tree the strength to stand tall and resist the force of the wind. When you turn that wood into biochar through pyrolysis, something incredible happens. All the water and other materials bake away, but the basic framework of those tiny tubes remains perfectly intact. The carbon essentially forms a strong black skeleton around this original wooden blueprint. Because all these tubes are aligned in one direction, up the trunk of the tree, the resulting biochar is extremely strong when you press on it along that same direction. You are pushing down the length of all those reinforced straws, which makes it very difficult to crush. It's a fantastic example of nature's brilliant engineering. However, if you turn the biochar and press on it from the side, it's a completely different story. Pushing from the side is like trying to crush that bundle of straws by squeezing it. It's much, much easier to do. The scientists found that some biochar was over 28 times harder along the grain than across it. This directional strength is what makes biochar so unique. Unlike steel, which is equally strong in all directions, biochar has a preferred direction of strength. This isn't a weakness. It's a special feature that we can use to our advantage in very clever ways. Think about it this way. A rope is very strong when you pull on it, but it offers no resistance if you push on its side. Biochar is similar. It has a built-in direction. By understanding this, we can design materials that are strong only where we need them to be. This allows us to make things that are not only tough, but also incredibly lightweight. We don't have to waste energy and material, making something uniformly strong when only one direction matters. This is smart, efficient design, and it's all inspired by the simple, elegant structure of a tree. So, we have this amazing new material that is hard as steel, super lightweight, and comes from trees. What can we do with it? The possibilities are really exciting and could change the way we make things. Because biochar is full of tiny organized channels and is also a form of carbon, it's perfect for creating advanced electronics. For example, we could use it to make high-strength electrodes for batteries or supercapacitors. These devices could store more energy, charge faster, and be much lighter than the ones we use today. Imagine a phone battery that lasts for days and is made from sustainable wood. Beyond electronics, its unique structure makes it a fantastic filter. Those tiny parallel channels that give biochar its directional strength are perfect for letting liquids or gases flow through in a very controlled way. We could design highly efficient filters that clean our water or air. Because we can control the size of the pores by choosing the right wood and the right heating temperature, we can customize these filters to capture specific pollutants. This could lead to better water purification systems for communities or advanced air scrubbers for industries, all using a material that started as a simple tree. Of course, the most obvious application is in building things. While you wouldn't build an entire skyscraper out of it, you could use biochar to create lightweight composite materials. Imagine mixing biochar into plastics or other substances to make them stronger without adding a lot of weight. This could be used in cars, airplanes, or even sporting equipment. Making vehicles lighter means they use less fuel, which is a huge win for the environment. These new biochar-based materials could replace heavier, less sustainable materials, giving us the performance we need in a much greener package. Even in traditional construction, biochar is already showing promise. Other recent studies, like one from July of this year, have shown that adding biochar made from rice husks to concrete can make it stronger and even better at blocking radiation. This is because the fine biochar particles fill in the tiny gaps in the concrete mix, making it denser and more durable. So, from high-tech batteries to stronger bridges, this humble wood-based material is poised to become a key ingredient in creating a more sustainable and innovative future for all of us. Ultimately, the discovery of steel-hard biochar is more than just a cool science experiment. It's a powerful reminder of how we can work with nature to solve some of our biggest problems. For centuries, we have relied on materials like steel and concrete. They are strong and useful, but making them consumes a tremendous amount of energy and releases a lot of carbon dioxide into the atmosphere, which contributes to climate change. We need to find better, more sustainable alternatives, and biochar presents a fantastic opportunity to do just that. It provides a pathway to high-performance materials that are actually good for the planet. The process of making biochar is a form of carbon capture. A growing tree pulls carbon dioxide out of the air. When we turn that tree into biochar, we are locking about half of that carbon into a solid, stable form that can last for hundreds or even thousands of years. If we use that biochar in a building or a battery, we are effectively taking carbon out of the atmosphere and storing it in our cities and technologies. This is the opposite of what we do now. It's a way to build a world that is not just carbon neutral, but potentially carbon negative. This whole idea is part of a bigger movement called green engineering. It's about looking at nature's designs, which have been perfected over millions of years, and learning from them. A tree knows how to be strong and lightweight. A seashell knows how to be tough. By studying these natural blueprints, we can find inspiration for creating materials and technologies that are efficient, resilient, and in harmony with our environment. This biochar research is a perfect example of that. We didn't invent a new molecule. We simply uncovered the hidden potential within a structure that nature had already designed. As we look to the future, we face challenges like climate change and resource scarcity. The solutions won't come from just one place. They will come from brilliant ideas, from science, and from a renewed appreciation for the world around us. Discoveries like steel-hard biochar show us that some of the best answers might be waiting right in our own backyards, within the humble and beautiful structure of a tree. By learning from nature, and using its genius wisely, we can build a stronger, lighter, and much greener world for everyone. Now that's science.